Hi there, welcome to this basic tutorial on using R as well as how to do data management using the R program. I'm Ryan Falk. I'm a postdoctoral fellow in the School of Biomedical Engineering at the University of British Columbia, Vancouver campus, and today we're going to be working on a few different things. First, we are going to be talking about why you should use R. Next, we'll talk a little bit about learning the language and how the language works and what to expect when you're coding. Third, we'll talk a little bit about downloading and installing the program. And then finally, we'll talk a little bit about how we can manage our data and some simple ways that we can do that. So first, why should you use R? Well, one of the main reasons that we like to use R and why so many statisticians love R is because it's incredibly flexible. It allows you to do so many different things in terms of your statistical analyses, whether it's things as basic as a t-test or an ANOVA, or as complex as something like multiple mutation or machine learning. Next, the cost of R is nothing. It doesn't cost anything. And unlike other statistical programs such as SPSS or Stata or SAS, there is no cost to using this program, and that's one of the great benefits of it. Third is the benefits of R is the data visualization abilities of R, specifically with regard to ggplot2. And we'll talk a little bit more about this in October when we have our in-person lecture. Next up is R is also a really sought after ability for data scientists, and something that you can actually include on your resume if you're applying for a data science job or something along those lines. And it's something that's really sought after from young professionals. In addition, R is something that's constantly and consistently updated, so you can always expect new things to be available from R and new software programs, new statistical packages to be available for looking at your data in different ways. And then last but not least is the capabilities of open science using R, meaning that we can check other people's work and confirm the accuracy and validity of it. So next up, let's talk a little bit about how we do coding. So normally when we code, we just write some code, we try and execute it, and then we realize that it didn't work, and then we have to fix all the bugs in it in order to make sure that it works. And the main reason that I tell you this or show you this little joke is that it's really a process to do coding, and this is a normal part of the process, is learning how to code and learning what works and what doesn't work. So just realize that this is going to take time, and you will get better with it the more that you practice it. So it's okay if our code doesn't work at first. It will work over time. And with that said, this is why Google is going to be your best friend when you're learning to code. I use Google all the time to look up how to get something to run, to look up errors in my code, to make sure I understand what's going on. Next is when you actually get something to run, it's important that you save your code because you're going to use it again and again and again. And so it's important to save what we've done in order to make sure that we can use it in the future. Third, just remember that clunky code, even if it's not super sophisticated, is fine as long as it works. It's better to have something like this than something that doesn't work at all. And then last but not least, just remember that you will get better with time and with practice. Everybody gets better. Okay, so for the rest of today, we're going to talk a little bit about how to download R and install it, and then we'll go over the basic skills of data management that you're going to need in order to use the program. Okay, so next what we're going to do is we're just going to download R. In order to do this, we're first going to go to r-project.org. From here, we're going to have this screen that shows us some updates on R that are available, as well as recent versions of R that may have come out. You can also follow the R project on Twitter if you wish, but that's something that will provide you with more details about what's going on with the most recent versions of R. From here, we can just go ahead and we can click on the link to download R. As you saw just a second ago. And then what we're going to do is we can see these different versions of R that are available, or different software packages that are available for R. And for here, we're just going to download R directly from Simon Fraser University. As you see, you can just click on that link right there. And then we'll have several different versions. One's that is available for Mac, one for Windows, and one for Linux. For Mac users, we'll click on that link, and then we'll just go and we'll click on the most recent version of R, and we'll download that in just a moment here. And so if you just allow us to download it, then you'll go ahead and download it, and it should take a few minutes to download that version of R. Now, if you're a Windows user, we'll go ahead and we would click on the link for Windows, and then we'll just download R for the very first time. Okay, so once you've gone ahead and downloaded R, you can just go ahead and click on the package, open it up, and then just agree to the terms and conditions, and then just install R. And it shouldn't take very long to install the package, and no, you won't need to restart your computer after this. So now that we have R downloaded on our computer, we're next going to install something called RStudio, which is an IDE which allows for a user-friendly environment to use R in. To do this, we're going to first go to rstudio.com, and from here we're going to go and click on the Downloads tab, and we're going to download and install either the Mac install or the Windows install. And just go ahead and click on either of those, and this will take just a few moments to download, and then once it's downloaded, we'll go ahead and we'll install it on our computer. So once we have RStudio gone and downloaded, we're going to just go ahead and install it. On Mac, this is pretty straightforward. You're just going to open it up and then pull it and drag it into the applications folder. For Windows, this might be a little bit more complicated. You might have to go through and install just similar to what we did before, but it shouldn't take too long to open back up. Okay, so now that we have our copy of RStudio and R downloaded and installed on our computer, we're going to go ahead and we are going to open up our copy of RStudio. To do that, we can either go to our Launchpad if we have a Mac, or we can use the Spotlight terminal as well. So if you just type in Command Spacebar and you were to type in RStudio, then you should be able to open up RStudio pretty easily. If you are working off of a Windows computer, then you would just go to your Start menu, and then you would go to your Applications, and you would find that RStudio has been installed as well. So when we open up our copy of RStudio, we're going to get this screen in particular. That's going to show our console here in the left hand side. Then on the right hand side, we're going to see our environment, which I'll explain in just a little bit. And then in the bottom right hand side, we're going to see our files, another tab called plots, which is where all your plots and graphs are going to show up. Another tab called packages, which is going to show all of the individual packages that you have installed in your copy of R. And this is going to become important because we use these individual packages to do different functions within R. So some of these packages are for graphing, some of them are going to be for specific types of data analysis and things of that nature. Then we also have this really great menu as well for help. The tab for help can provide you with a lot of individual information about how to use certain functions within R. So for instance, if we don't really know how to use a specific function in R, so let's just say that I'm interested in trying to summarize my variables. So there's this function called summary, which we'll talk about in a little bit. But if I was really interested in trying to understand how to use that function of summary, then what I can do is if I just type it into the search bar, then that will give me some individual factors about how to use it, some idea about what the different commands are for that individual function, and also some examples of how to use that function if I'm interested as well. So let's go through an example of how we're actually going to use R and how we're going to analyze our data. In order to do that, first, let's just go ahead and let's go to the top left-hand corner to that plus sign, and then just click on that, and then go ahead and click and open a new R script. So what you're going to do within this R script is this is where you are going to be writing the code necessary to run your data analyses. And so let's just start with a basic understanding of what the language actually looks like. So if I were going to try and just make a vector of 5 different numbers, and a vector is just a single line of numbers. So a matrix is where you have multiple numbers making up multiple different rows of data, something along the lines of perhaps this would be a 2 by 2 matrix, but a vector is just a single line. So 5, 4, 3, and then 2, that would be a vector. But if we want to write that into our environment and save that, then what we have to do is first we have to name whatever that data vector is going to be called. So for instance, let's just go ahead and call it data just for simplicity. And then if I were to create an arrow pointing towards data, and then I use this C function, and that's going to give me the ability to write a vector. So for instance, let's just say I'm making a vector of 4 different numbers in a row, 4, 3, 2, and 1. And then if I were to go ahead and I go to this run function up here, then as you can see, that's going to save that vector of data under my environment. So now I have a vector of data consisting of numbers 4, 3, 2, and 1 that's saved in my environment. And let's just see if I actually wanted to print that, or if I wanted to run it, then I would just go ahead and I can go back here and I can go to data, and then I can call it by data, and then just run that individual line. And then you'll see that in my console, it will now print whatever I have typed in to the command down here in the bottom. And so you can see that now I have these 4 numbers printed all in a row, 4, 3, 2, and 1. And so this vector has been saved, and it will print when I call it using the command data. Now you could also do this directly within the console if you're interested. Maybe you don't want to save the command in your script. So instead, you could actually just run it from the command line or the console line instead. And so that may be something that you're interested in as well. And so you can just go ahead and do that. Now, there is an easier way to run data every single time. You don't have to go and move your mouse button up to the run function here in the top right. But what you can do instead is you can use the function command return on a Mac, and in a Windows computer it would be control return. So just a slight difference. So in a Mac it's command return, and then in a Windows computer it's control return. That's going to allow us to go ahead and run whatever code we want without actually having to click on this button every single time. Okay, so now that we understand the basics of how we would code something for simplicity, let's go ahead and let's talk a little bit about how we would manage our data in RStudio. So first, let's just go ahead and let's click on this broom. This is going to delete that vector data from our environment. So now we have an empty environment. And now we're going to talk about how we can find the data that we're interested in. So again, in the bottom left-hand corner, you can see all these files that have been loaded into my computer, and that's what my set working directory is. And I've already preset this up as well, but I'd like to show you how you would do this on your own. So to do this, what you would do is you would go to Session, and then we're going to go to Set Working Directory, and then we would choose our working directory of interest. And so as you can see, I already have this folder that's been created called rhelp, and this is going to be where all my files of interest are associated for what I'm going to be talking about here today. But what you would do is you would just go ahead and navigate to whatever folder has your data of interest, and you're just going to go ahead and you're going to open that folder. And you can see that I can't actually access my Excel spreadsheets from here. So for right now, we're just trying to navigate to the folder that we're interested in using for any of our analyses. Once I've gone ahead and I've opened that folder up, you'll see that this command has run here in my console, and that's telling me set working directory means I've set the working directory to this folder. And you can see that there's some commas, there's quotation marks around it indicating what the name of the folder is and where it's located. So if you wanted to, you could save this individual folder or the location of this folder and the command that you're going to use in the future to access this folder, rather than having to use the menus and the tabs in order to locate that. So to do that, we would just go ahead, we can move this command up into our script, and we could just label it as something like set working directory if we wanted to too. And this hashtag that I'm using here, that allows me to save something as a note, so it's not going to be run as script, it's just going to be run as a note for whatever it is that I'm talking about. So you can see here that now I've just got this command for set working directory. So in the future, if I want to do this, if I close the program down, then I can open it back up and go to my script, and I can just run that command, and it's going to go directly to this folder in particular. Okay, so now that I've got my working directory set, the next thing that I'm going to want to do is I'm going to want to open my data of interest. And so for right now, I have this test data that's already located within this folder, and this is something that you can go ahead and you can access yourself from my GitHub account that's already been posted as well. Once you go there, you'll see that if you download these data are going to be available for you to play around with. So what we would do is we can just go ahead and click on the data, in particular this test data set, and we can go ahead and click on import data set. And from here, what you'll see is this is going to provide us with the actual data that we have, and you'll see that there's a couple different rows where we have these individual IDs, we have the participant's age, their biological sex, education, their height in centimeters, their weight in kilograms, their body mass index, and then their wage, which is a variable that I've come up with by just as a random variable. And then also we have their medical expenses as well. So these are data for you to use, but they're actually not real data in any way, shape, or form. So please don't read too much into them. But if we go ahead and we look in the bottom right-hand corner, we can see that, again, there's code that we can save. And so we can copy that code if we're interested, and then we can just hold on to that code, because that will allow us to hang on to that code and use it in the future if we're interested in doing this using coding, rather than having to point and click and go through the point and click functions. So once that we're done with that, we can click import, and that's going to import these data. The way that we can, once we've done that, we can also just import that code or copy and paste it if you have done so yourself already, and we can just put this down as import data, or whatever you would like to call it. And so this is going to call the library readxl, which is a package in R. And so if we were to just go to that package tab and we scroll down, we should see the library readxl in here, and see, if you look there, it's been clicked on, and then once that's been clicked on, then it will allow us to run the function readxl and import the data, test data, from my working directory, and it's going to import it as test_data, and that's exactly what you're seeing here. And then lastly, what you're seeing is you're seeing the command view data, which then allows us to view what the data actually look like after importing them into our environment, just like that. You could also just click on the data. You don't have to use the command view data, and that's going to just open it up whenever you're interested as well. Now let's just say hypothetically that you clicked or you scrolled down through your packages, and you notice that before you even run any commands, that readxl is not something that's currently listed in your packages in R. That's okay. What we can do is we can then click on this install function, and then from here we can just go ahead and we can type in readxl, and that's going to allow us to download that from the repository, the CRAN repository. That's understandable. That will happen from time to time. You can just go ahead and you can click on that, and then it will allow you to download and install that package. Okay, so let's just say assume now that we've gone ahead and we've imported these data. We have these data listed within our environment, and now we're ready to start doing some data management and a little bit of data analysis as well. So first, let's just say that we're trying to understand what our column names or our variable names are. Now, obviously, what you could do is you could look, go ahead and click on the data themselves, and then you could go ahead and look at what each of these variables are called. But this is a relatively small data set. We only have, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 variables. Let's say if we have like 30 or 50 variables, it's not going to be the easiest thing in the world to open up these data and then count all or look at all the variable names in particular. So we might want to have an easier way of knowing what our variable names are. One way of doing this is to use the call names function. And all you would have to do here is you would put in call names, and then in parentheses we would then put in the name of the data set that we're looking at. And from here we can see very easily what each of our individual variables are. And if you look here as well, we can also get the number of variables that we have. So I have 10 variables, which makes sense because if you look here, we have 10 variables and 120 observations as well. So once I've done that, I might be a little bit more interested, in trying to understand what each variable actually looks like. So let's just say I'm interested in looking at age. Well, to do that, what I can do is I can then go ahead and open up that individual variable. To look at that variable, I'm going to enter the name of my data set, and then I'm going to go ahead and put a $sign. And once I put a $sign, I can just go ahead and I can scroll to whatever that variable name is, or I can write it out, and then from here I can just go ahead and I can run the command, and that's going to show me all the individual ages for all 120 observations from this data set. So again, that's one way of looking at those data. I could also do it a separate way using that view command that we went over before, but remember, you have to type it in exactly as it has been put inside, or all commands have to be written exactly. So for instance, let's just say I use a lowercase view, and then I go ahead and I type in those data, test data, and then I go ahead and I type in age. And if you look, there's not that command view. So remember, you always have to use the commands exactly as they were originally written. So there's not any flexibility about putting the command names in a different format. So everything has to be exactly as the program is expecting it to be written in. So now that we can look at individual variables, let's try and understand what those variables actually look like. And there's a couple different ways that data can be written. So if we just were to look at the data in particular, we can see that we have a bunch of numbers for some variables, but then we also have variables that are character variables. And if I were to just go ahead and I would to put my mouse over the individual variable, I'm going to find that some variables are going to be characters, some variables are going to be listed as numeric as well. And so I can understand what types of variables I have by just running my mouse over those variables when I'm viewing the data. But if I want to do this more directly, I can also just use the type of command. And if I go ahead and I just put my data set in again, and I were to just go ahead and run that command, that's going to tell me that the variable age is going to be a double. What a double refers to is it just means that it's a numeric data variable. But if I were to run this type of command using the variable ID, then that's going to be listed as a character. So we can see that there's going to be differences in terms of the variables that we see in our data set. Okay, so now that we can at least get some basic ideas of what our variables look like, let's go ahead and let's see how we can manipulate our data set to get individual data that we want and improve our ability to run specific analyses. So for instance, one thing that we can do is we can subset our data, meaning that we can delete variables that we're not interested in examining, and that may make it more difficult for us to just run different analyses. So for one example, let's say that we want to select certain variables. So if I were to do this, I'm just going to create this new data set we're going to call data2, and then I'm going to use the command subset, and then I'm going to enter the name of the data that I was originally running, and then I'm going to select specific variables. And one way I can do this is I can just go ahead and I can select age, and then if I run that command, then I'm going to have this new data set that's just going to be 120 individual observations of age, and it's just going to be a vector of age and age alone. But let's say that I wanted to remove age from my data set. Well, all I would need to do is I would just need to put a negative C behind that variable, and then that's going to run everything wherein I'm going to exclude age from my data set. So again, that's one way of doing it, is we can just select individual variables that we want to include or we don't want to include. So, one more time, let's just say hypothetically that I'm interested in including a data set that only includes ID, age, and biological sex. Then I could just go ahead and run that command. That's just going to leave me with a data set that only includes ID, age, and biological sex. And this C refers to the columns. So this is just a notification for the columns that we're selecting for. We're selecting for column ID, column age, and sex. And when we put this negative sign in front of it, this means exclude those columns from whatever we are selecting for. Now, another way that we can call variables is we can just use their number in terms of the order that they appear. So for right now, let's just go back to that call names function. And if we were to look at test data, we see that there's these numbers that appear right next to each of our columns. Well, this is just referring to the column number. So we have 1 through 10. So theoretically, if I wanted to just include a data set that consisted of ID, time, age, and sex, then what I could do is I could create a new data set wherein I'm going to take from test data, and I'm just going to include the rows 1, 2, 3, 4. And that's going to create a data set that, as you can see, I only have 4 variables. I have ID, time, age, and biological sex. But I don't need to just do it with a comma after every single data variable that I want to include. I can also do that by just calling for 1 through 4, and that's just using the colon. So a colon is going to represent a continuation of the number of variables that we want to have. So I want variables 1 through 4 in this, or 1 through 4 of the columns that I'm looking for from test data. And so I can do that again, and that still is going to give me variables 1 through 4. And if I wanted to remove the variables 1 through 4, then I would just use the negative C, and then as you can see here, I've got a difference in terms of the variables that are included in this data set. Okay, so next, you might be interested in trying to rename variables. So sometimes variables may be a little bit difficult to be able to call easily, and it might be a pain to call them or type them out one after another. So for right now, let's just go back to that original data file of test data. And if you look at the individual, all 10 of the variables that we have of interest, we can see that some variables, as you can see here, are going to be very easy to name. So ID, time, and age and biological sex are easy to name. But then we have variables like height and centimeters, weight and kilograms. Those are going to be a little bit more difficult to call easily. So if I was just going to go ahead and call those variables in my script, so let's just say hypothetically I was interested in calling height in age. So for this, if I look down, this variable, it's got quotations around it, it's got spacing, it's got parentheses, so it's going to be difficult for us to call very easily. So if we were to be smart about this, we probably would want to rename this variable to something else and make it a little bit easier for us to be able to call these variables. So one way that we can do this is using the rename function, which is in the library of dplyr, Dipler. And if we load that library, and again, if you don't have that library automatically in your package or in your copy of RStudio, then you would just go to Packages, you would click on Install, and then you would type in dplyr, and then that will install the Dipler package, and then you just need to type in the library command, and that will load that package for you once you type it in. Okay. So once I've loaded Dipler, what I can do is now I can use this to rename variables. So what I'm going to do is I'm going to create this new data set. We're just going to call it data 3 for right now for simplicity. And then I'm just going to use the rename function from Dipler. And what I'll do is I'll then just go ahead and enter the name of the data set wherein I want to rename a variable. And then from here, I'm just going to go ahead and I'm going to enter the new name that I have for whatever it is I'm interested in. It's then going to be followed by an equal sign, and then you're just going to go ahead and you're going to enter the old name for whatever the variable was called of interest. And so once we run this command, what we'll find is that if we were to just go ahead and we were to look at data 3, we can see that now height has a new name, and now it's going to be just height, and no longer we don't have these annoying parenthesis signs after we call for height. Now you can do this with multiple variables at the same time, so you don't have to do this individually for every single variable that you have in your data set. So for instance, let's just go ahead and we're also going to do this for weight as well. And we're going to just go ahead and we're going to rename weight to just weight and get rid of that annoying little kg sign as well. And you'll notice that again, that removes the weight command too. So once we've done that, we can go ahead and we can rename variables to whatever it is that we're interested in renaming our variables to. So that's a very nice, easy way to rename something. Okay, so what if we want to make a new variable? Well, one way of doing this is, for instance, we might be interested in creating a new body mass index variable, something that's a little bit, we can recalculate it separately. So for right now, let's just go ahead and we're going to use the data set 3 for right now, and we're going to create this new variable which we're going to call BMI2. And so what we're going to do is we are going to calculate BMI again, and just as a reminder, BMI is kilograms divided by meters squared. So what we can do is we can go ahead and we're going to take our variable for weight. So we have weight, and then we're going to divide it by data 3 of height, which is again in centimeters. So we're going to first need to convert our centimeters into meters squared. So again, 100 centimeters are in a meter, and then we're just going to go ahead and we're going to add this uppercase sign, which is going to denote a square. So again, when we're looking at the if we're trying to create a square of a variable, we would just use this square sign. And then the other signs that you may also be using as well is you're going to use an asterisk for multiplication. You may need to use a log for being able to get the log of a number. And then if you want to exponentiate a number, it may be an exp, and that's going to exponentiate any number that you have of interest. But generally speaking, it's just going to be plus, minus, and then a asterisk and a division sign for dividing variables as well. So right now we have weight divided by height in meters squared. And so if we were to just run that variable of interest in question, if we go ahead and we open up our data, we'll see that we now have this new variable that's been created. And obviously my calculation's a little bit off, so forgive me for that. But you'll see that we now have height in centimeters divided by weight in meters squared. And so you can see that there's definitely some issues with height and weight that aren't adding up. But that's okay for our purposes today. But we now have a new variable for height and weight that's going to be based on these two variables of interest. Okay, so we now have a way of being able to calculate new variables as well that are based on a continuous number. But we might also be interested in doing some other types of calculations as well, based on whatever we have an interest in. So let's just say that we are interested in creating a new variable that is going to be a character variable for defining education. And so just as a reminder, from this data 3, we can see that education is going to be this number from 1 to 3. So it's just going to be a number from 1 to 3, but that might be a little bit difficult for us to be able to wrap our heads around. We might not remember what each of these different variables are called. So we may want to create a new variable that's going to describe education as a character variable. To do that, what we would do is we would create a new variable. And to do this for right now, we would first use a new variable name. So we're just going to call it edu. And from here, we're just going to label that NA. And what NA means is, in this case, is that there's nothing that's going to be attached to that variable for right now for any participant. So we'll go ahead and we'll run this, and then what you will see is, if you look over to the side, is there's going to be nothing but NAs in this variable edu for right now. But now we're going to identify different parts of that variable based on another variable, in this case education. So first, what this is going to require is we're going to go ahead and we're going to type in data 3 and then go to the variable education. And then from here, what we would first do, sorry, I screwed that up, but what you would do is you're going to type in this new variable education, and then in brackets, you're going to go ahead and you're going to put in the old name of the variable and then put whatever number it is that you're interested in identifying as a character. So for instance, let's just start with education of 1, and that's going to be somebody that's in high school or that has a high school education or less. So for right now, we're just going to type that out as education is high school if they have a 1. And then let's just say that somebody that has an education that is a 2 is somebody that has a at least some university. So in this case, we would just put some college or some university. And then lastly, a person that has a education of 3 is going to be somebody that we're going to say has at least a university degree or higher. So for here, we would just go ahead and put university or higher. And so if we were to run these 3 individual columns, then what we would see is, if we go over and we see this variable, now we have that individual is going to be set up based on their high school, their university, or their university education or higher, and you'll see that it lines up with whatever we labeled education is. So the edu variable is now going to be listed based off of the education variable. Okay, so if we want to transfer those variables back into numbers, it's pretty straightforward. It's actually the exact same thing, just in reverse. So hypothetically, if I'm interested in creating this new variable, but I want to create a number out of it, then what I would do is I could create this new variable. We're going to label it edu2, and then I'll take the data3 and I'll take edu, and then I would just go ahead and I would label it based on whatever it is previously, and then I can now put a number behind it as well. So I'm just going to do this with 1 for right now, just for simplicity. I'm not going to do it with the other 2, just so we can get an idea. But we create this new variable of edu.2, and as you can see, there's now 1s attached to wherever a person has high school labeled. So again, same idea, it's just in reverse now. Okay, so next, let's say that we want to change the type of variable that we have. So for instance, if we look at this variable of edu.2, so let's just take a look at what type of variable it is. So if I were to go ahead and enter that variable, we'll see that it's labeled as a double. But let's say I want to make it a factor. So a factor in this case is going to be something that that we can use in terms of being able to look at different groups. So a factor would be like a grouping variable. So in this case, if I want to create this as a factor of some sort, then what I can do is I can run the following command. So let's just say that I want to create this new variable for education. So again, if we were to just look at what education has been labeled, it's been labeled as a double. So for simplicity, let's just go ahead and see if we can make this into a factor. So what we can do is we can go ahead and we can enter a new name for it. So in this case, education2, and we're going to use the command as factor. And that's going to go ahead and we're going to be able to list our new variable as a factor variable. So I'm going to take education and I'm going to list it as a factor variable. So if I were to type that in again, let's see what it looks like. And again, remember, you're going down to the education variable. Now it's listed as an integer. And an integer is okay because that's what we're looking for anyway. It's just that would be the same as a factor variable. So let's say that I want to reverse that. Then what I could do is if we have data that are listed as a integer, then we could change that back into a factor. So for right now, let's just go ahead and we're going to stick with the same idea. So we'll take the data from education2, and rather than as factor, we're going to put in as numeric, and that's going to change our data back to a numeric variable. So again, we're going to take data3, and we're going to go ahead and we're going to put in education, and we're going to run that. And then if I were to run that command again, then what I'll see is now it's listed as a double. Okay, so with that said, there's just one or two more things that I'd like to share with you for today, and then when we meet in person, we'll be able to start doing some of the basic analyses that we would hope to be able to do with our data in R. So one thing that we can do again is if we wanted to just include one time point. So again, there are 3 time points in the test data that I have available. The one thing that we may be interested in doing is looking at baseline differences between people. And for this, we could just go back and we could create that subset of data that we may be interested in looking at. So in this case, we're going to stick with test data for right now, and we're going to go ahead and we could enter in time is equal to 1 because there are 3 time points and they're labeled as 1, 2, and 3, and we're interested in only looking at time point of 1. And so now we have a data set consisting of 40 individuals only at time point 1. And this may be something that's going to be more interesting for us in the future as well. So for right now, what we are going to do is we could look at some descriptive aspects of participants in this study. So what we would look at first is we could look at using the describe command, we could look at some basics in terms of understanding there are differences in a couple different variables. So if we use the describe command, that's not, then what we would actually have to do is we'd have to enter a variable that we're interested in. But if you look here, that library is not installed. So as you can see, that would require us to go ahead and open up the library of Psych. So if something's not working, it probably means that the library that you're interested in using is not installed right now, or is not being run in particular. So for right now, I'm going to enter in the library Psych, and then when I run that command again, then I'll see that I will get this description of individual variables. So for right now, this is just looking at the variable of age, and I'm going to be seeing that the mean age of participants is 71 years with a standard deviation of 6.4 years with a median of 73. So we can get some basics in terms of understanding descriptives of the variable as well. We can try to do that with the full data set as well if we're interested, and as you can see here, we can actually get this for all the individual variables that we are interested in looking at. Now let's just say by chance that we're interested in trying to understand how there might be differences between groups in certain variables at a time point. Well, one way that we could do that is we could use the describe by function, and then we would just go ahead and we would call two individual variables. So we might be interested in looking at baseline differences in age based on biological sex, and the second variable should be a grouping variable of some kind. And so what you can see here that in this case, let's just label women as ones and men as 0. And we can see that the mean age for males is 70.58 versus females, which is about 74 years of age. So there appear to be some differences, although we don't know whether it is statistically significant. And so to do that, we could just do something like a t-test. And we could just go ahead and we could enter in t.test. And then if we were to put these two variables again into this function, so baseline age, and then we would look at baseline sex, and we were to put that little squiggly line in between, we could see that we're looking at a two-sample t-test, and we can see that there is not a significant difference in terms of age based on biological sex, although the p-value is about 0.10, and there is the confidence interval suggests that there might be a difference, but perhaps the sample size isn't large enough to show that there is a difference between groups. Now, if we wanted to look at looking at a grouping variable to see if there's differences, in terms of something that's not a numeric variable. So, for instance, let's just go ahead and look at education. So we'll go ahead and we'll use baseline education, and we can see that there are some differences in terms of the sample. So just going back to that way that we were grouping participants, there seem to be more participants who have a high school education than there are individuals who have some college or a university degree or higher. So those are the basics for right now in terms of what I would like you to be familiar with before we meet in October. I've provided on GitHub a number of different practice problems and other code for you to be able to run on your own if you're interested, if you want to develop your skills. The other thing that I would mention right now is the swirl package, which I will provide more information on as well. But if you wanted to as well, you could try to install and then run the swirl package, which is a really interesting and nice way of being able to look at individual data, being able to learn how to use R. And so this package will actually allow you to learn R in a very simplified format. It will teach you the basics of coding in R. So I highly recommend using that as well if you're interested in learning more. And so with that said, we'll just go ahead and we'll have a few concluding remarks, and then we'll be done. So to recap, what we've done today is we've gone over an overview of how to use R. We've then talked a little bit about downloading and installing the system as well as RStudio, and then also gone over some basic data management skills. For more help, I would recommend downloading the Swirl package, which is a great way of learning the basics of how to use R as well, beyond what we've gone over today in this video. In addition, you can also find several different opportunities to build skills at my GitHub page, where I have the actual copy of the test data set available for download, as well as several different code examples and practice problems. And then I also have an explanation available as well for running the Swirl package and learning how to make sure that runs on your computer. So thank you very much for your time, and I look forward to seeing you all in October.